Hello 108 students, Mr. McHugh here with you. Welcome to section 2.6 where we are going to work with compound inequalities, and we're going to tackle page 1 here on this video. And I want you just to think about compound meaning more than one. So we are simply going to go ahead and have two inequalities, and we're going to see what the net result is based on whether we're going to find the intersection or the union of two inequality sets. So to get this going here, look at objective 1 here, and it says the intersection of sets. Intersection, think of what is common to both of them. And I drew a little intersection of a street here in class. I usually talk about like the intersection. We're close to Ada campus where Maple Grove is running north and south and Overland is running east and west, and right at that moment when you are actually at the intersection where the light, you are on not one but actually on two streets at the same time for that split second while you're crossing over. So think of what is common to both sets. That's what they want you to remember here. Now in mathematics we use a lot of symbols, and sometimes it gets a little hard remembering them all, but think of your little decoder ring and put this in there. And I like to remember this, that when you see the arch, that the A-R-C-H, the A looks like an arch, and that's how I remember. And you want to think of what common or the intersection. What do you have in both sets? Okay, so to get this concept going, if I had a set A with the following elements or numbers 1, 2, 3, 4, set B had 2, 4, 6, and I asked you to find, you see A intersect B is how you would say that. You think of the arching, think of and, we'll think of what elements are common to both, and you can see I found 2 was in both of them and I found 4 of them. So the solution to this problem, A intersect B, is 2 and 4. Okay, so that's when you've got the inequality and you've got the word and a couple steps here for objective number 2. You want to think about inequalities with the word and. Solve each inequality separately. You might have an algebra equation. You got to work them down, find the value for x, its inequality, and then graph it. And the solution set is where they overlap. Think of and think of the arch. Okay, that's the hardest part to these problems. You get the concept down. Now take a problem here like example 3. And they've got these two inequalities and they've got the word and. You want to remember that you want to come down and find the overlap. You want to find the arch. Okay, now these are fairly easy algebra equations. Isolate the x term, add 2 to both sides, divide by 3, and you find out that x is less than or equal to negative 2 1/3. Negative 2 1/3, so I made a little typo there. Okay, so you've got that. If you go graph it, you can kind of see, you find negative 2 1/3, you're going less than, you're going this way. And now you turn around and you take the other inequality, solve for x, add 1 to both sides to isolate the 5x, divide by 5 on both sides. Hey, it's a positive, so we leave the inequality alone. Don't forget the warning, if you divide by a negative, then you must switch the inequality sign, but we do not do it here. So we find all of x such that x is less than or equal to negative 4. We're going less than, we put the brackets, and now what you're doing is you're going to do them on both sides. And so the overlap region here, this one's a little unconventional. You usually don't see this one here. Here, where does the overlap happen? Well, they both are going less than, so if you start with this one, 3 going down between 3, negative 2 1/3 and 4, there's no overlap. So starting from negative 4 going down is the overlap. And here's the set notation to go with it. You're going the smallest values, negative infinity, going up to and including negative 4. Okay, so that's that section. Objective 3 now, we're going to take the word union. The word union has got the letter U, and we use that symbol, the letter U, for union. And so it's nice to know that if you think of union, you're thinking of the word or. All elements from both sets. You're going to include all elements from both sets. Okay. So, Mr. McHugh here, that's it for this section. I will come back and we'll work on page 2, and this is a short section, so we'll be able to knock this one out. Okay, I'll see you on page 2.